Today we are going to see the topic called memory organization in 8051 microcontroller. So these are the important features of 8051 microcontroller. So in 8051 it consists of two separate buses for both program and data. So it has two memory spaces of 64 KB with a size of 8 bit for both program and data. It is based on 8-bit CPU and 8-bit accumulator and 8-bit B register as a main processing block, which is shown in the block diagram. So other important portions are included with the 8-bit and 16-bit registers and 8-bit memory locations. It has some amount of data RAM built in the device for internal processing. This area is used for stack operation and temporary storage of data. 8051 is supported with on-chip peripheral functions like I/O ports, timers, counters, serial operations. The memory organization in the 8051 architecture provides with the on-chip memory expansion capabilities, which supports the physical address spaces functionality separated at the hardware level by different addressing mechanisms used for read and write control signals or both. For accessing the internal program memory, internal data memory, external program memory, external data memory, and on-chip special function registers. The program memory area, that is EEPROM or flash memory, is used to serve extremely large and never lose information when the power is removed. Program memory is used for information needed each time power is applied, while initialization of values, calibration of data, keyboard lookup tables, etc. along with the program itself. The program memory has 16-bit address and any particular memory location is addressed using the 16-bit program counter and instructions which generate the 16-bit addresses. On-chip data memory is smaller and therefore quicker than program memory, and it goes into a random state when power is removed. On-chip RAM is used for variables which are calculated when the program is executed. In contrast, the program memory on-chip data memory access need a single 8-bit value which is used for constant or another variable to specify a unique location. Since 8 bits are more than sufficient to addresses 128 RAM locations, the on-chip RAM address generating register is single byte wide. Different addressing mechanisms are used to access these different memory spaces, and this greatly contributes to microcomputer operating efficiency. The 64 KB of memory in the program consists of an internal and external memory portion. If the EAP is very high, it executes the internal program memory unless the address exceeds from 0000 to FFFFH, and the locations 1000 to all F are then fetched from the external memory. If the EA pin is low, the 8051 fetches all instructions from the external program memory. In either case, it is a bit program counter operates with a 16-bit operation for the addressing mechanism. So here it also used for the programming code with the help of the external interrupt, that is a reset for 000H, external interrupt for 0003H, timer 0 for 000B, external interrupt 1 for 0013, timer 1 for 001B, and serial port communication for 0023. The data memory access space consists of an internal and external space. External memory can be accessed with the help of the MOVX instruction using DPTR. These on-chip data memory locations 128 or 256 bytes with the total size of data memory can be expanded up to 64 KB in external RAM devices. The total internal data memory is divided into three blocks: lower 128 bytes, higher 128 bytes, and with special function register space. The higher memory is again shared with the special function registers for ports, status control bits, timers, registers, stack pointers, and accumulator. Even though the upper RAM area and SFR area are shared with the address locations that can be accessed through different addressing modes. Direct addresses higher than 7FH accesses SFR memory space, and indirect addressing above 7FH are access 128 bytes of the higher range. The lowest 32 bytes of the grouped into 4 bank registers, which is selected with the help of the program status word, that is flag register. The program instruction refers these registers are with the help of R02 or 7. The second bank register, that is bank 1, is indicated with the flag register, that is program status. The next 16 bytes above these bank registers is from the block of bit addressable memory space. The instructions of 8051 contains a wide range of single-bit processing instructions, and these instructions can be directly accessed to 128 bits of this area. The SFR space includes port latches, timers, and peripheral control registers. All the memory members of the 8051 family having the SFR at the same SFR locations. There are some 16 unique locations which can be accessed by the bytes and also bits. The SFR memory locations are above 80 bits. Since the addresses 002 7FH are the addresses of RAM memory, the SFR have addresses between 80 to FFH, but all the address spaces 80H to FFH is not used by the SFR. The unused locations are reserved and must not be used by the programmer. So in this one, the blue shaded locations are for port number 0, port number 1, port number 2, and port number 3 registers. And yellow shaded registers are for control status for registers. Okay. T-con is for power control, T-con is for timer control, T-mode is for timer mode register, T-con for serial control register, IE for interrupt enable, IP for interrupt priority, PSW for program status, that is flag register. The green shaded one is the special function registers denotes the registers of B register, accumulator, serial buffer, timer 0 and timer 1 registers, stack pointer, DPTR, that is DPL and DPH. So in this one, we need to know about the stack pointer, which is a 8-bit register. It is used to keep track of memory space where the important register information are stored. When the program flows begins to executing a subroutine, the stack portion may be placed in anywhere in the on-chip RAM, but normally stack pointer is initiated to 07 after a device resets and grows up from the location 08H. The stack pointer is automatically incremented or decremented for all operations using push or pop instructions and for all subroutine calls and returns. In this thing, the program counter is a 16-bit register giving addresses for next instructions to be executed during the program execution, and it always points to the program memory space. The data pointer register details a 16-bit register that can be used to fetch any 8-bit data from the data memory space. When it is not being used for this purpose, it can be used as a 8-bit registers, that is DPL and DPH. In this one, program status word used to check the current status of the arithmetic and logical operations in different bits. The 8051 has 4 mathematical flags that responds automatically to the outcome of the arithmetic and logical operations, and three general purpose user flags. And the map flags are carry, auxiliary carry, overflow, parity flags, and one user flag and two bits is for a selection of register bandwidth, RS0 and RS1. So these are the memory organizations of the 8051.